What's up, everyone? I forgot to do some things. I'm gonna go do those right now. Welcome to this little app. Now let me remove things from my person. There we go. I'm gonna BRB, but I'm not really that far away. Let's just play some music. No, play this music. Hey, wait, come on. Okay. Now that I've ruined everything forever. Yeah. Back at it again. I know a lot more about 555 timers now, though I didn't really need to know anything more about them. I just made a dumb mistake. Let's fix this, and then fix that. And it's meow. Alright, so today, just like last time, I'm going to be building the Atari Punk Console, except we're going to actually finish it this time. Probably delve a little more into the characteristics of why it works the way it does, because I understand it better. Okay. I really need to make another scene where they're divided in two different things. That little thing there is almost useless. Like, check it out, you can see color down there. Yeah, great. Alright. We're going to switch over to our useless camera. Move my phone. We're not going to need my phone. Alright, so like last time, this is our dumb schematic. I don't really expect you to follow it. You can barely read it probably. Whatever. But it's basically just two 555s with some capacitors and some resistors to control how fast they charge, which in turn controls how fast the waveforms move and oscillate. Same thing. I'm going to actually have to look at it, even though it's a fairly simple circuit. Okay. You know, I think I kind of want a light, like, I don't know why, but I'm getting pretty crazy shadowing over here. So let's grab a little light of some kind. I need to get a little desktop lamp. Why do you look red? There you go, be white. Lights are stupid. I really don't like them. And of course now it's gonna like try and compensate and keep it dark no matter what I do. Alright, let's just pretend that it's nice and bright, and I'm just gonna go fix it. Might be able to walk over here with this. Yeah, because I wired it properly this time. Let's just fix this real quick. Doop-a-doo, webcam properties, configure video. Can we just focus pretty much on the breadboard area, maybe? Should have done this beforehand, but you know, not very smart. Ooh. That looks okay. Now we just focus. Ooh, what a messy focus control this camera has. Come on. Come on. Come on. Come on. Come on. And come on. My goodness, the driver is so buggy. Come on. Just do what I want you to do. Just need the keyboard. Okay, that took an act of Congress. You're not currently working, so I guess that makes it even more impressive. It's 5600K light, so don't be dumb. Backlight compensation, no. I need to get some more contrast. This isn't enough contrast. Okay, alright. Sorry about that. Maybe now you'll actually be able to see what I'm doing, and it won't be confusing and stupid. Alright, so we got our breadboard, and now we're just going to wire it up for power. It's going to use, just like last time, our Wegmans battery. It's important that you get batteries that are from grocery store chains. That way you know that they're clean and food safe. Now I want to eat a battery. Alright, so from this point, we don't really need the battery anymore, except that like unplug and plug back in everything. Am I getting messages? I gotta stay on top of my messages, guys. Meow. Do good. Yay. Do hood. What? Whatever. Not a cat, you're strange sometimes. Alright, so we want to set up our power rails. And that means first running power out to these rails here and then connecting them over here. And then the thing I forgot to do last time, which royally screwed me, is that I didn't connect these two rails. I knew that you had to, and I just didn't do it. So I'm good at things. Alright, so positive, positive. These are a little harder to put in than the other test leads, but they also stay in. They don't form a kind of annoying short contact, so I prefer them. Also visually, it's more obvious what they do, I think, than having a wire that comes up and all the way over. But there's, you know, jumper wires are still really useful. Next, long hole. These are too short. What's up, JT Sands? Oh, you were here last time, I remember. I think I remember. Yeah, I do. No, I do not have Xbox, sorry. I mostly do PC games. I have a Switch, but I barely use it. Do you have an Xbox? That's right, Mixer is pretty much like a Microsoft platform, isn't it? Hopefully you don't have to have an Xbox to stream on Mixer, do you? That'd be a really weird requirement. Come on, I want leads. Why do they all have to be in the bottom? More leads, more problems. Come on, come on, come on. Be nice to me. Okay. Alright, now we've got these rails powered properly, but I'm going to double check real quick. Looks like you look good at that. I don't know. Just wiring up leads. Anybody can do this. I'm gonna clean these up a little. I don't like how that looks. This lead's just way too long. I'm gonna do a shorty. Also, thank you. I'm pretty sure that was a compliment. You are nice. It's a cat. No, don't tell people my secrets. You look good at that. Okay, I got you. Thank you. Okay, these are wired up and there isn't a big glob. It's a cat with no ears. This should be fixed. All right. Cupcakes, you're relentless. You happy? Meow. I feel like such a dork. Alright, so the big terrible mistake I made before was that I didn't connect these two lines to these, and then I started using them like they were connected, and then I got a really bad sinus headache thing going, and A cute dork. Yeah, I can tolerate that. Cute dork is tolerable. Alright, so now we connect these to these, because if you don't, you just get sad later, and apparently get sick also. Thanks for the follow, Dan Dirty. What's the name? I think Dan is one of the most common, like, names, right? I know like 4 Dans. And it gets really annoying sometimes to differentiate them. So you got Danny, you got Danny, Dan, and oh, thanks for the zaps, JT Saints. Alright, so now we got our buses, well, not buses really, they're buses for power, but not usually how you use that term. Alright, so I want an indicator light to know when we're turned on, so I'm going to go and wire that up real quick. I don't want to sit here and squint at these resistors, so I'm just going to use the multimeter to get their values real quick. Looking like we got 1K ohm. That's what I wanted. Alright, so we'll just pick you up. Positive. This is where the electrons like to go. I'll bend you over, because there's not really any reason to do anything else. And then hook you up here. This will be our power indicator, so we'll know, because a lot of times I'll just be messing around and I'll leave the circuit plugged in because there's no visual indication that it's actually plugged in. And now let's just bridge it over so the current can flow across it when we have potential. Oh, that's too big of a lead. On mobile phone apps are just lurking. Good luck with circuit board electronics thingies. Oh, Kryzen, you're actually alive. I texted you today and you didn't text me back. Alright, so now we actually have an indicator light. Let's see how hot the resistor gets. Shouldn't get very hot. I never know if you're just going to check out permanently because you take so much flipping Benadryl when you sleep. Alright, so now we got a useful little circuit. Yay! Alright, now we can start actually following the schematic that... Oh, I forgot the guy's name. Oh well, he's famous old prototyper guy. I'll probably remember it eventually. He has kind of a strange name. And he's responsible for the initial step tone generator that this thing was called. And then it got popular again in like the 90s. Because people started nerding out over... No, it was the 2000s. Like when people started like modding Game Boys and stuff. No, that was like... I want to say that's like 2010. I actually don't know when that scene popped up entirely. I modded a few Game Boys though, I remember that. Alright, so let's start our first oscillator. We're going to be putting this one in a completely astable configuration because, well, we need some kind of clock signal to trigger the other timer. It would take a lot of Benadryl. A lot of people, it's kind of interesting because like I was watching an article about the suicide forest and they were talking about how a lot of people would try to take sleeping pills and it would actually just ensure like an incredibly slow death because they would take them and then trip out really bad and get super dehydrated, but of course they didn't bring a bunch of water with them. So then they would basically die slowly of dehydration after tripping out for like 12 hours. Seems awful. This happy lab here. Alright, now we're just going to hook up power to our chip because most chips need power. It's going to be pin 8, which is VCC. Go in. There we go. Alright, and we're just kind of using the battery over here as the switch because I'm not going to put a switch in here, and I've got the indicator. I don't have to worry about anything. Just like in driving, if you put on your indicator, then you really don't have to look before you pull into the other lane. That's a little joke. Alright, so we got VCC over here. And then we'll hook this part up to ground. Now our chip's got potential. Alright, now our trigger pin, I'm pretty certain needs to be hooked directly through the capacitor to ground. But then it's, yeah, okay. So the trigger pin, which is pin 2 right here. Basically we want the trigger pin to, or the node on the trigger pin to slowly amass current, and then once it gets high enough we trigger, and then all the current will flow the other way through the discharge pin. And that's what kind of gives us our fancy clock cycle. Voltage divider, yada yada, you get the idea. Okay, so we've got our here. Now we need to connect, we need to connect that trigger. Oh, this is not what I should be using. Sorry. This is too high of a value. It'll oscillate too slowly because it takes too long for the cap to charge. We need to be using 103. Yep, that's going to be 0.01 microfarads. This is what we want, is this little guy. We use this guy later in the circuit, just for basic decoupling. Okay. Now we need to, I guess before we go any further, I'll go ahead and put in the first pot. We're using 1 meg, even though they call for 470 in the original circuit to 500K. But we just lose a little bit of our top end, it's not a big deal. Meow. Okay. So now, unfortunately with these, it's a lot easier to, you know what? Heck this. You guys aren't going to be able to see anything if I wire it up like that. But I might have to wire it up like that. Yeah, I'm going to have to. Poopy. Oh well, we're going to have to use jumpers for these just because it's a pain to root them around otherwise. Actually, no, let's try not to. Keep the board nice and clean looking. So our source come into here. This will give us our positive voltage, which we then step down based on where the potentiometer is turned. Come on, you booger. I'm going to put these in before I put in the pop. What's going to be the best one for this? So then the output will probably be like right here. We'll just bend you in. And 7 is discharge, so. And discharge is what will basically flip the direction the current's going when the chip flops inside, which means that it switches over to another state. Okay, so now we got that set up. Now we can put our potentiometer right here, and we won't have a big gobbly goo wire mess to deal with. It's all hooked up. You might like consider coupling the first pin to the last pin just to not have a wire flapping, but we're not going to worry about it for a prototype. Alright, and then we need another 1K resistor. I think that's one, but I'm going to check real quick, because visually I'm always a little bit crappy with doing caps. This is a 10K. Not quite what I'm looking for. I might have to go grab a 1K out of the box. 80K? This is probably 100K. Beep boop wires. Okay, here's a 1K. Alright, and we do 1K from discharge to threshold. And then threshold goes, threshold 6, right? Yeah, so it's right here. Discharge to threshold, that just connects them with a little bit of resistance. And then we're gonna wrap one wire from our threshold pin over to our trigger pin. Our threshold and our trigger pins basically just trigger the chip at different times. One triggers at 2/3 voltage, or 1/3 voltage, and one triggers at 2/3 voltage. So we basically get an oscillatory effect. Oscillatory, that's not a flipping word. But anyway, so yeah, trigger pin. All right. Now, unlike last time, I can hook this up if I want to. But unlike last time, I'm gonna hook up the oscilloscope, and I'm gonna kind of show you how it works from a TSA watch list material. Yeah, like it's got a wire in it and a battery. You can't carry batteries on the plane, but the TSA doesn't have jobs anymore, so it doesn't matter. All right, so yeah, oscilloscope's booting up. Right, go. And while it does that, I'm gonna hook up all the different leads. It's so scurry. I mean, it's a little pretty creepy. I'm fancy? Just loud. Okay, so a lot of what dictates how the timer works here, I'm gonna the Rigol and all. I've had this for a long time. I've actually got a really nice scope over there. It's an analog storage scope. It's literally the Twitch list on Spotify. Because now they say they'll mess with streamers who play like copyrighted music and actually go after them. So. This is going to be my ground lead that I hook all my oscilloscope grounds to because I'm lazy. But it's fine. Okay. Alright, so yeah, I don't even know what I'm playing. I'm sure it'll go into some like abomination here in a little bit, but for now it works. Okay, so where's our cap sitting at right now? I want to see if I've got this hooked up right or not. It does not look like it. Okay, so our dark blue channel isn't hooked up. Thanks for the follow, Benja FT01. Check out that night flight station. It won't trigger any copyright bots. It's my go-to workstation. I'll have to keep that up. I'll have to keep that in mind. I'm gonna turn off all the other channels. Don't need them right now. As we hook them up, we'll turn them on. Oh, and this one's set to 500 millivolts. It's per division. Useless. At least for what we're doing. No, not 10 volts. 5 volts. There we go. Center it. I'm slightly confused. Do I have it set? Oh, I bet I have it set to 10x on the probe yet. It needs to be 1x. Because we are doing 1x right now. 1x. Oh, and it dropped it back down to 500 millis. Of course it did. 50, 50, 20. I was turned the wrong way. Alright, so 5 volts. We've got a... Let's set up our... I'm going to kind of just look at it for a second, and then we're going to go into... I think I'm going to... I think I already have my triggers set up, so let's go into normal trigger, menu, pulse channel 1, let's do that. Source needs to be channel. Shut up, multimeter. Source needs to be channel 4. And it should pretty much trigger immediately. No? Is it not? That's weird. Okay. Why am I missing my trigger? Oh, it's because that's actually kind of strange. It's high for a really long time. So let's... Okay, so I'm going to do some measurements real quick. Let's do our... Okay, so our negative width is less or greater than 200 microseconds, and our positive width is about 3.4 millis. It doesn't seem completely wrong. Let's see if we can actually change it. Yeah, we can. Slow it down a little. Looks like the slowest it can go is about 7.4 milliseconds. The bottom width always stays fixed, I think. Because I think this technically would be R2, or is it R1? No, technically it should be changing. Oh well. Either way, let's hook up the speaker and see if it does what it did before. I'm gonna put the speaker all the way down here. I'll characterize it further in just a little bit, but right now I'm just trying to... Can I get this all the way down here? That'd be cool. Should probably unplug it. So you gotta love those indicator lights. Oh man, hopefully tonight's stream goes a little better than the last one did. The last one was a little bit painful. Hey, stop turning off and on. I knew I should have put a real switch in here. Okay. There we go. We can just pop this one off to ground. If it can reach, should be able to. Did something come undone? Oh, you have the wrong... That's the trigger pin, not the signal pin. Oops. Sick. Okay, so... Whoa, hey, shush. It's not as loud as it was before. I kind of appreciate that. I'm not sure exactly why it's not as loud as before. I just looked up Night Flight Radio, shared link in Discord. It only shows up on mobile? That's weird. Huh. Oh, that sounds horrible. Alright, well let's... Hey, shut up. I think technically I can make it louder by coupling the trigger or the output signal with the 9 volts. I'm actually kind of curious, so I'm going to do that real quick. Because I know in Texas Instruments datasheet, they actually recommend that you couple it. I'm going to try it, just see what happens. Probably destroy everything. No, that makes it worse. Hey. Note to self, 9-volt battery connectors do not make good switches. Okay. All right, is anybody interested in seeing the math for why the PWM goes at a certain rate, or should we just go straight to building the rest of it? In fact, I'm just gonna go straight to building the rest of it. Once it's done, we'll do all the other little stuff. We're gonna leave this one hooked up to the signal though, because I wanna see our first signal. Now we're gonna install okay. Do you go search for Night Flight, Black Cab, then start radio. Okay, well that's not a big deal. I might do it at the end just to pad everything out, because this is going to be a pretty fast build. I am going to add a couple of mods to it though. Nothing complicated though. Just a volume knob and a... not that it even needs it, but... Hey, where'd our sound go? Didn't even do anything. Help. Wait, is this battery dying maybe? I think our battery might be dead actually. It's alright, I got more. There's more where this came from. I have been using the crap out of it, so. Oh yeah, it's like 4.3 volts. Whew. All right, time for a new battery. That's why it was so quiet. Okay, I should be able to keep my mic on while I walk over here. Need a wireless left, please. No. Yeah, I got a ton of Wegman batteries. Yeah, it's actually a lot of people are surprised because 9 volts are, you know, whoa, 9 volts. But I think they have like 500 milliamp hours. It's like garbage. It's not good. They're very weak compared to most batteries and other sizes, but they're old and they're popular. They're stupid. I think they have some other characteristics like the connectors being cheap. Here we go, this is probably gonna be really loud. Yeah, there we go. Also, the light's a lot brighter now. $18,650. It would honestly, it would probably kill the speaker, but I'm pretty sure. I'm trying to remember the voltage. An 18650. It's alive. But I am actually kind of confused about something. Oh, that was short. Okay. It is indeed alive, but it needs a little more. Wow. Oomph. They're 4.2, then I think they would be fine actually, because these little 555s can go up to 18 volts. But an 18650 would last a lot longer. So I think I'd need some protection on the discharge and stuff. Yeah, 35 amps. But I mean, amps are just a function of what, you know, the device draws. So like if it doesn't want that many amps, like these on their output, I think they can only sync 300 milliamps. So not really something, this circuit isn't gonna just randomly consume 35 amps. Okay, so now we've got our second 555. We need to wire it up to, everything's visible, right? Yeah, okay. We need to wire it up to ground. Pin 1 goes to ground. Make sure that's unplugged. Thanks for the follow, Almot 2000, sorry. I started to say it and then my brain said, wait, there's no S in that name. Thank you. Come on. Thumbs up and smiley. Both good choices. Okay, so I think our trigger pin now is going to, because what we're going to do is we're going to run this in a monostable mode, which means we're going to use an external trigger, and this is the guide that's going to give us the external trigger. That way we can have a, what's the best way to describe that? It'll basically give us two sets of frequencies to work with. Not really frequencies, but kind of. That doesn't really make sense. I'm not explaining it right, but basically it'll just, we'll basically get two oscillators. That's the only way that works to put it, I think. We get two oscillations. I could probably add another one off of this one and give it a different speed and actually make it even more interesting. Maybe if I have time I'll do that. Alright, so we need to take our signal pin out of our astable config 555, which is basically giving a clock cycle. These things can give clock cycles, by the way. They're pretty accurate up to, oh crap, I forget. I think the CMOS ones can go up to a meg, but I don't know about. Alright, so we're going to hook this straight up to the trigger pin, and that will cause this thing to latch over. No, not latch, but flip-flop, so we still have to have it, cycle back over so it can be triggered over and over again, otherwise it's pointless. So let me get the schematic, check what I'm doing. Yeah, the monostable output's actually really simple. What we're going to do now is we're going to take this green wire out because the output's in a different place now. Although it kind of sucks because the green wire is like clamped in by a bunch of other wires. Because I did not think this through. Alright, green wire you go. So we're going to put our deep-a-doop. Yeah, we're going to decouple our output and then put that directly into the positive of our specker. That's too short. Alright. Come on. I'm gonna have to stretch that cap out a little bit. Too short. There we go. Just make sure the cap can reach. Gotcha. Okay, so now we've got our output, we've got the chip powered effectively, and we've got the chip to where it's going to be triggering properly. Now we just need to effectively hook our discharge and threshold pins together and sync threshold down to ground, and we'll kind of do the similar circuit over here where we're charging up the cap. Oh my god, so extra. But this will basically get charged and discharged as the switch flip-flops. Trying to remember, that threshold's pin 6, so it's gonna be. The music is so extra. Is it too loud? And then we're gonna hook these two bad Larrys together. 6 and 7 need to be together. I actually want to do a YouTube video on the 555 timer. It's right where it should be? Awesome. I've gotten pretty good at eyeballing that, but every once in a while a song comes by that's been like mastered improperly and it's like, oh, I can really tell. I don't know if Spotify does any mastering to its audio before it comes out. It'd be nice if it had the option. Just like set a dB limit or something. Alright, so now we've got our charging circuit pretty much set up and ready to go. You're in ground, right? No, you're in VCC. Bad. Okay. And now this is the part where we hook up our second potentiometer, which gives us our control over the secondary oscillator's actual... I think these capacitors might be slightly different values, which will give us not the authentic Atari Punk Console, but we're going to be modding it anyway, so it's going to be kind of irrelevant. Okay. So now let's just get power, positive 9 volts into our cap here. Need a longer boy. By the way, I've been loving the Pi-hole C Miami. I didn't realize how much I wanted it until I started using it. Plus being able to use like octopi.lan, because you can mess with the DNS mask entries, so I can like pfSense next. I would love to do a pfSense setup. And I could sell my current router, though I guess I could just use it for Wi-Fi access. Okay. Yeah, we're piping right into the discharge, which is center lead-in potentiometer is always the output. There's never always in electronics, but it's pretty short thing. And this wire is also too long. I need a shorter one. No, this one's too short. I'll make it fit. Get in there. Go, 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 go. This wire doesn't know who it's messing with. If it did, it wouldn't work at all. Oh. Okay, we're just gonna find a longer wire. Perfect. Can always count on purple. Except when you can't, get in there. Okay. Alright, now I can just wire this back up. Now theoretically, this should be complete. I don't think it is though. And I figure there's probably going to be at least one thing wrong with it. I'll probably hook this up wrong. Interesting. That's kind of interesting. The electrolytic seems like it's kind of killing the... Let's see. Oh, that would be great if you could get a Ryzen in those. I mean, they're eventually going to get cheaper, so... Yeah, I bet you will too. That'd be wonderful. I'm itching to do another computer build. Okay, so we're going to do this. We're going to do it without the cap, because I think with the one... Actually, I don't know. I think it's because I'm not coupling the output signal properly, but... We'll just assume. Just ignore while I plug this in while it's running. There we go. It's happening! Good old Ron Paul. Okay. As you can tell, it makes noise. Alright, kind of want to die a little when I listen to that, but, you know, primo. Oh my god, can I make that not so loud? Okay, so the first thing we're going to do is add a volume knob. Proxmox? I've never even heard of that one, so I feel stupid. Okay, yeah, I don't want to waste battery. Thank you for reminding me. Alright, so I've got this potentiometer for this purpose, which is an A500K. You'll notice there's an A in front where these are B. There are two different types of potentiometers. A KVM with a pretty GUI. Ooh. But basically there are two types of potentiometers. There are a lot more than that, but these are the two basic types. You have A's, like this one, and they interpolate the voltage values logarithmically, which works better for audio, where our perception of sound isn't linear to how many decibels are actually being cranked out. And these here are linear because a lot of times you need a linear response. So for audio, you almost always use these type A potentiometers. So trap for, never mind, I'm not gonna say that. It's like I can interpolate. See my Emmy, have you been hitting the sauce? I'm just familiar with the word interpolate because I've done like lots of like graphics programming, and you use that a lot in like IK solvers and stuff. It's all, you have like routines called lerp and slurp, like linear interpolation and spherical something interpolation. It's been a while since I've done it. Okay, so this is going to be our output, so I'd like to take this signal and yeah. Ideally, I want to actually build the full thing on stream. I have this really cool old container I found. It's like a shaving cream container or something. It looks really slick, and I think it'd be cool to have an Atari Punk Console installed inside of it. Okay, so I just want a volume knob so I can leave it hooked up a little bit longer, because right now it's kind of, I don't know, kind of don't want to live if it's plugged in for very long. I kind of want to hit the sauce a little bit too, but I'm not going to probably. Probably stop sitting on my legs. I have a really bad habit where I'll just like curl my legs underneath myself and just sit on them for like hours at a time. And then I wonder why I feel like crap. And that's weird, what's wrong? Oh, that's right, I folded half of my body underneath it itself and sat down. I'm gonna use it. I'd imagine it doesn't work for most people. But alright, this is some pretty weird sounds. And I think this resistor is probably, or this potentiometer is way too high value. Because most of the potentiometer just gives me nothing. Maybe I'm stupid. Okay, I'm tempted to just put a normal resistor in here and see what happens. Let's just slap one in and see what happens. Maybe I can just make it a... Well, that doesn't do anything because it's way too high value. Put random resistors in until one works. Alright, see you, man. You better come back. No, it's okay. Alright, so I guess we'll just leave it hooked up the normal way. It'll be annoying and you'll have to deal with it. But we are going to mod the circuit a little bit. Shut up. Please. Come on, this wire now for some reason decided it's going to be really hard to plug in. So you're going to have to shut it off. Okay. I feel like it's not quite making the sound it's supposed to. It's a little frustrating. Like, I don't feel like I'm getting the reading out of my oscillator that I want to. But it does look right when I look at it. No, it's pretty much correct. Okay. It's just not changing the sound at all. Am I triggering this properly? No, they aren't really working quite that well together. Okay, so this one is definitely feeding in. It's almost like this is not in a record. I'm gonna check the wiring on this potentiometer. You're going out to here, and you're going into the discharge pin, which you set over to the threshold pin. There's a charging circuit sitting on it. Does anything have to loop around? Not really. Oh, you know what we're not doing? Forgot to hook up the reset pins to, they should be floating high instead of low. We might actually be running into an issue there. We're signaling. And then reset pins pin 4. So we're just gonna whack it in there, pull them high. You do that for both ICs, maybe that'll make a difference. Probably not though. But that was a dumb fault on my part. Okay. Alright, let's see if that makes any difference whatsoever. I mean, it broke it, but... Oh, wait, no, it's because I'm resetting this one every time. Gotta put them high. There we go. Okay, so now something's off. I think maybe the battery just isn't plugged in or something. Output trigger, reset CC. That's weird, now we're not getting anything. This is dumb. No, something probably just came unhooked because, yeah, it was the resistor. Okay. Oh my god, okay, that's driving me nuts. Weird. Why would this one be the only thing that's controlling it? Its output's here. They accidentally bridged something they weren't supposed to? Like, what the heck? It went straight out of that pin. I'm watching it, but... Oh, that's weird. And annoying. So... Oh, that's kind of interesting. Ooh. That's annoying. I'm sorry. So it seems like for whatever reason, this is actually kind of... bizarre. A little bit. I don't quite understand why, but it seems kind of like when I adjust this one, it's also adjusting this one. That really should not be the case. And for me, this one has too big of a... Let's see, so this one should be one larger. It should be 0.1. What do we got here? That's a 104. I think that technically makes it smaller. Let me go get a 103 out of here. Because it's going to be 10 and 3 zeros versus 10... No? Okay, well, I'm gonna... I know the 104 is wrong, so I'm gonna go get the 103 real quick. And then I'll come back. I can keep talking, but... gotta get the thing. Okay, we're looking for 102s, I think. 101, 103. Oh, where's the 102s? I know I got them. I know I got them. There they are. Okay. They're so small. Alright. I think we have the wrong values for our capacitors, which I think could be causing kind of a weird inconsistency with the clock. Not inconsistency, but like one clock's being driven way too slow, so it kind of commands everything else. Thank you, stomach. Okay, so this one, pull it right off the trigger pin into this. Why is it so much quieter? Yeah, the other knob doesn't really do anything. It's annoying. I'm gonna pop speaker out and have a look at some things. This knob really isn't changing much. Alright, time to hook up the scope to... Oop, my hair's a mess now. Time to hook up the scope to the second oscillator and see what the hell it's doing. For this, I guess we will use our yellow, which is our channel 1. It up to the ground. Love ground. And then our signal out would be here. And okay. Interesting. Okay, I'm just going to touch over here so you can kind of see what I'm doing. I'm not really. Okay, so let's set off our standard channel and just look at what we got here. Like a standard square wave that you can control the length of. Yeah, see, ideally you should be able to be like hearing that, but for whatever reason, Like, I do think that the circuit's doing what it's supposed to. Both knobs control the pulse widths, but... Let's see. Oh, they're kind of overlapping, I think. And that's making it not really... I don't know if this is what it's supposed to do. It seems fairly... I don't know. It seems like that's what it should be doing, but the sound just isn't there. I thought it would sound a little different. Alright, I'm gonna try and put the 10 back in, now that we've got it kind of where we want it. Hey, shut up. Okay. Maybe it is getting like weird coupling issues or something. Suddenly I can't plug the stupid speaker in. Come on, go in. Did bend the lead? Yeah, I bent it. Okay. Now I just took up a quickie test lead here. There we go. The signal was getting coupled. There we go. That's what it's supposed to sound like. That's cool. Alright, well, we got the basic circuit built. Happiness. Interestingly, we had to decouple it like that. Cool. Alright, so there's one modification I want to make to this where I'm not entirely sure it will work, but I do want to try it. And I've got these FSRs, they're like Velostat. They're basically potentiometers, but they react to squeezing from pressure. And I had them on before. I want to put them in parallel with our pots and see if we can't tap out some of the like interesting little timing sounds that we get from this. And I want to see if that like makes it more of a physical instrument rather than being this is. I mean, there's something to be said about tweaking knobs, but shut up, I didn't just say that. You know, I'd like to have something that you can like tap. I think it would be cool to maybe put these underneath the enclosure so it's not obvious they're there, and then you just tap on it and you get that little bit of like feedback. Okay, we're done with the circuit. Don't need to really look at it ever again. Oh man, I need some shorter alligator clip leads. Alright, so we're going to set up our... Oh, I guess it'd probably be good if I actually showed you everything again. Alright, cute little resistors. And I guess I'll just go ahead and put the alligator clips on them first. We'll try on one channel first, see if it works out, and then we'll try on the other. Alright, let's pop some test leads out so we can get these things in parallel. Parallel. Alright, so ideally we should be able to do this to this. Come on. And then we should be able to couple our output. Like coupling. You always use that word incorrectly. Thanks for the follow, State Police 216. Alright, now let's see if we get any sort of effect out of this, or if it was just a bad idea. Yeah, that's what I wanted. Well, it's not as extreme as I would like. It sounds horrible, I mean... Yeah, I like that. Alright, so... Originally I tried to put them in series, which was a stupid idea, but I didn't think about it. I was just like, let's hook them up. But, you know, these things, if you're not touching them, they really don't give you any, it's like pretty much not connected, so they wouldn't really, you couldn't use these at all. Alright, more alligator clips. Commands. I have a dumb bot, but I'm not super familiar with it. Do I need to get another alligator clip? No, got it here. Try to use my commands without saying hi. I see how it is. My commands are up here. Don't joke. Alright, let's go ahead and get our other potentiometer hooked up. Our other FSR. Dealy. And then we can make some awful music. I'm excited. So I guess we can go through and kind of explain how the 555s work I'm pretty sure I'm gonna be completely done. I mean, how long have I been at this? An hour? Yeah, it didn't take very long to build this thing. Didn't think it would. Alright, so we've got our two pads here. I'm not gonna get so close to the camera. We got our two pads here, and we got our two adjustable knobs right here. Sounds like some kind of horrible bagpipes. As this gets low, it doesn't do a whole lot. That's fun though. It sounds terrible, but it is fun. I don't think you can really tap out. Can't really tap out a beat on these because they sound. You have to tap pretty hard to really get anything going there. Oh, it sounds terrible. I love it. All right, so we've pretty much gone through. I'd like to add the volume knob and actually make it work. I think that would be kind of cool. Maybe now that we have the decoupling IC on here, maybe I can do that. IC, it's just a component. Alright, so let's see if we can hook this bad Larry up. This would be my output. So I'd really like to make it quiet enough that you can kind of hear it without it just being this ear-destroying cacophony. Alright, let's see what happens. It just didn't work at all. Poopy. I know the signals are getting generated, so it's an issue of these things not being hooked up right, maybe? I don't know. Am I beep booping successfully? Yes, I am, actually. Let me know if you want to hear it. It sounds terrible, but it's not meant to sound particularly... Oh, I didn't have the ground hooked up. Alright, here we go. I'll do you a little demo, Cupcake, since you probably weren't listening. It does sound terrible. but you also have these touch controls here. I mean, it's a not particularly beautiful sounding instrument. Okay, it's awful sounding. I got it. But I'm still happy it works. So that took me an hour. I kind of feel stupid. So let's go through some of the basic equations that, Let's go through some of the basic equations that drive at least the A-stable 555 timer, why it works the way it does. I'm going to unplug the speaker for these because it's very loud and kind of awful sounding. It is fun to play with, and at some point what I want to do is build a keyboard for it, and then I can use trimmer pots and use buttons. I might be able to use these FSRs too, to actually have a key bed where it just plays tones when you push the buttons. I think that would be a better option, but I'm not going to be able to build it right now because I don't have all the parts for it. I need to order some more trimmer pots. But once you do that, I could set up the buttons, and then each potentiometer would create a different frequency, which you can figure out because these things are fairly math driven. There's a little bit of drift in the components, but if you dial them in just right, no problems really. Then I could have like a 1 octave keypad on it, and that'd be kind of cool. And then I could add all this stuff too, like a pitch bend touch, but I'd really like to just have this on its own, add some jacks, and a couple of other things. I think it'd be cool. Okay, so I'm not going to take this apart to do this, but I am going to remove these touch resistors because they'll muck everything up. Okay, so R1, R2. So the first 555 goes in what's called an A-stable configuration. That means there's no external triggering, nothing is feeding it a clock. It's purely going off of the behavior of the components it's attached to, plus its internal comparators and flip-flop, and a couple of BJTs, I don't know. Okay. So let's kind of clean up our oscilloscope area here. You're good, but I don't want you anymore. We're not going to focus too much on the second 555 timer. Good luck with your sadomasochistic beep boopy machine. Thank you. I'm having pretty decent luck with it this time around. Okay. I'm covered in wires. Alright, so how we're gonna do this? Let's clear this kind of out of the way. I'm gonna go back to the webcam for a little bit here. Mostly because we're gonna be doing oscilloscopes stuff. Alright, so these things work off of a very basic equation. The A-stable configs do anyways. You have your basic high time and low time, and it's basically determined by this resistor, which we're going to pop out and replace with a known value, because otherwise I'm going to have to like measure it and then plug it into the equation. Better off to just pop it out, use a 1K or something like that. And then we're going to use this capacitor down here, and the basic equation is 0.693 times R1 plus R2 times C1, and that'll give us our high time. Then our low time is just 0.693 times R2 times C1. Look at my handwriting. But the other stuff is all just derived from the first two equations, basically. But we're going to actually demonstrate that it's true. But I want to use some known values for stuff, so we're gonna modify R1 and all that stuff. R1, R2, C1. So let's use a 10 mic, because with a 10 mic it'll actually be a little slower. I'll unplug the oscilloscope from there for now. Whack in our 10 mic where we had our like 10 picofarad. Wrong direction. Alright. Oh, sorry, I'm already getting the sniffles. Alright, let's get a 10K going. I'm gonna find a 10K resistor real quick. 10K resistor. After this, I probably will be done. It's gonna be a short show tonight. That's alright though. This is like a 100K or something. Yeah, you're 100K. I don't want you. I want a 10K. 10K. 1K. You're a 1K. I have a pretty slow multimeter. 10K. Here we go. Okay, so basically this is going to be our R1 up here, and so we want to replace it with a 10K variant. I have the yeah, here we go. Put a 10K variant in here. It's because I know the timing values, so when I go to check them, it won't be such a pain in the butt. And this is a 1K resistor that I pulled out, so we're going to put it basically where the potentiometer was. So the input for the pot was right here, and for some reason that falls straight through. It's almost like it doesn't have like the pads got damaged, probably because the potentiometer has such big leads. And then we can put it right here. So this is basically replacing our potentiometer. But what I want to do first is we're going to put our dark blue lead onto trigger. We're going to put our bright yellow lead onto our capacitor, because the capacitor charging actually plays a pretty huge role in the timing of the circuit, and the resistors just kind of change the dynamic of how fast it charges and discharges. Okay, so we're going to have to activate the yellow channel and the dark blue channel, and let's also hook up our pink channel to the actual output value. So we'll be able to see what it's outputting, how it's triggering, and why it's triggering. This is terrible. I'm going to get a regular cable. I'm going to make probably a decently comprehensive tutorial on YouTube about this, just because it has a few good ones, but I kind of want one that segues into building the Atari Punk Console, because I think that's neat to show practically. That's how I learn, so I always want to make practical stuff when I can. Alright, so this is going to be our pink. So we've got all these set up. Let me take it over the oscilloscope. And then we'll do some explaining, but first I'm gonna, where our measurements are, I need to clear them all, because we got a bunch. All items, delete. No, I hit the wrong button. Go back up. All items, delete. Okay. Okay, you should be able to read that okay. Alright, let's power up the circuit and talk. Well, this first. Let's power up the circuit and talk about it a little bit. Alright, what's our time? Okay, so right off the bat you can tell that the blue is maybe what's supposed to be happening to the blue isn't happening to it. And that's because our one of our wires is out. 1 second, I'll fix it. Yeah, the wire sending VCC to the drain in the threshold is not hooked up. Okay, now 1 milliseconds, way too fast. You can see that the pink's doing something. Let's just focus on the dark blue for now. All right, so if you look in close enough, you can see the dark blue is. Ooh, that's kind of an ugly signal. Am I doing something wrong? Yeah, let me double check my connections. I really shouldn't be doing that. Dark blue is hooked up to what? Yeah, dark blue is hooked up to the trigger. It shouldn't be doing that. So what am I doing's wrongs? Pin 8 goes to VCC. Yeah, VCC. R1 typically goes from VCC to the discharge, which then connects over. Oh, I see what the hell I did. I got a little confused. And this pops over to this resistor. But yeah, this should have been from here to. Wait, are those both supposed to feed into VCC? That's not right. I did something wrong. That's okay, I'll fix it. I'm just gonna wire this differently. So R2 goes to discharge, and then discharge can pretty much go. I mean, it does go to R2, but for some reason there's a 5-volt feed in here. It shouldn't have been. That might have actually been affecting the oscillator too. I had that wired up wrong. Oopsie daisy. I'll rebuild it after this to fix it. Okay, and then we are supposed to do this. And that's also not another thing I want to see really. It's not a square wave. I'm getting a headache. 1 second. Oh, I had coffee the whole time and I didn't drink it. I'm gonna have a little bit and then I'm gonna drink water. Oh, and I don't have any of it over here with me. I'm smart. I have coffee and donuts. And I have water, which I need to be drinking. Meow. You still lurking at Creed? Okay, I'm gonna eat donuts, so we're switching to DSLR donut cam. Okay. So I'm just rewiring it to make it a little simpler, because without the potentiometer, it's a little, I think it's a little simpler. Hooks into a discharge, and then that hooks down. In the midst of summer, it won't exist. This emptiness, it's just a blank slate. Waiting for a painter to interfere. That's interesting. Did I cook that up wrong? Because the threshold is clearly wired all the way over there to that. No, that's right. But that's really not what it's supposed to do. I've got this wired up wrong. Dom, help. Outputs here, we got a measurement here. Are you actually in your home here? think it's okay for this and this to be attached. And then this gets attached here. No, I missed. This gets attached right here. And that gets attached there, but for whatever reason now we're getting a... What am I doing with my life? It's just if I touch it, it gets like a little bit of AC coupling there. Why on earth is this happening? My stomach's not happy either. Out is being measured with pink. I'm curious, actually. I want to see what our pink does. Oh, it kind of wiggles around. It gets a little, like, our output actually triggers a little bit, it seems like. Alright, now it's time to actually look and see what the hell our capacitor is doing, which is, capacitor is yellow. Yeah, we can see actually the problem there because our capacitor is constantly charging back up and it's never really getting to discharge, which means that our cycle will never work. Now we have to figure out what the trunk that is, and I just figured it out. Capacitor plugged in backwards, so it was just never really discharging or charging. And that looks weird also, but I mean, so why aren't you charging? I mean, realistically, you should be. As you're coming around here, we got VCC. This loops around here. Yeah, you should be charging. Oh wait, the leads got bent around now. Jeez. Let's see if that fixes it. Still seems like it's having a kind of a problem. Well, one of these, my capacitor line came unconnected, so I took it out. Well, we're looking at it on a weird time scale. 500 nanoseconds? Why would I look at it in that? 20 micros. This is better. So pink is our output, right? So we're actually getting... That's not really... What is it doing? Alright, so these are dark... Dark blue is basically sitting on trigger, but they're both sitting on trigger, so... I don't think that should be. Yep, threshold comes around. And trigger is part of it. We are literally measuring the same pin, because I'm dumb. Weird. I mean, it's technically triggering. I don't know. I did it earlier. Alright, so I think what I'm gonna do is we're gonna cry? No. Maybe. Are we smelling things? No. I mean, I got the thing finished, but then I was basically going through how 555 timers work, and for some reason, smelloscope. Oh, I get it now. I mean, yeah, we are, but for some reason it wasn't working, so I'm gonna pop off all this extraneous circuitry that we were using. And we're just gonna play with one single 555 timer for a little bit. I guess I should have probably done this at the beginning rather than the end, but you know, I'm not very good at pacing. Get out of here. pin like cap. Does Pi-hole have an integration with Firehole? To be honest, I have no idea. Never really looked at Firehole too much. Maybe it does. I don't know. You're the security appliance expert. Okay, let's try and do that again with less failure. I'm gonna make a bigger version of that side window, I think. Okay, this should be easy. It'll take like no time at all. Famous last words though. This should be easy. It's not. Help. Pull our reset pin high. Power the chip. Actually, this is ground, I think. Yeah, pin 1 is ground. Ground the chip. Power the chip. Get in there. Okay, okay. No, Hey, television, turn back on. I think this stuff would definitely be more like suited to YouTube than doing on Twitch live. Certain things are great live, but I don't think doing this is probably going to be that interesting. Building like a printer or something purely physical, sure, but it's not like you can see the electrons flying around. Alright, so R1 from VCC. To pin 7. This is how we eventually feed our capacitor. But discharge can also go straight to ground, so. And then from here, connect R2 off. And I mean, we pretty much just go all the way over to the trigger. I mean, yeah, the trigger is basically connected directly to the capacitor. So, that's really all it should take to make this work properly. So now I'm gonna hook the scope back up. We're gonna watch. I'm gonna just look straight to the capacitor, basically, which is gonna tell us our trigger voltage. I think it might have been working okay last time and I was just being weird about it. And I'll just get the ground hooked up here. I love ground. Oh, it just goes high and then never goes low? Oh, no, that's good. Yeah, because the threshold's not being affected. I'm stupid and wired that up wrong. The threshold needs to also be a part of this. The threshold likes to be hooked up. Ah, darn it. Get in there. it up this way. I'm doing something wrong. I think I shorted something. Because now the light won't turn on. Oh, I think I unplugged the light. Thanks for the follow, Briny Badge 25 to 20. More electronic thingy's not behaving? No, it's behaving. I'm the one who's not behaving. I just wanted to characterize this 5-5 timer with an equation and show everyone because I think it's cool, but apparently when I turn on the camera my IQ drops like a lot of points. There we go. Let me just look here. Actually, I think it's working and I'm just being kind of stupid. What's up, Ackley? Having a good night? I have donut. Oh. Okay. The pink lead is my favorite. See my lead, it's pink. Pink is for girls. Okay, so I'm just gonna grab the output signal real quick. Oh, can I donate electrons for more donut consumption? No, you can't. That feature has been removed. Oh dang, would you look at that one. Alright, so, meow. I'm gonna switch over to the webcam real quick. Alright, so ignore, which one are you supposed to ignore? This one? Okay, so here you got yellow. That's the capacitor charging and discharging. And you can see how the capacitor discharging and charging basically affects what state the switch is in. Only you can prevent electrical fires. So you can see pretty much that the capacitor, I don't know why it's wiggling, probably shitty connection or something. But the capacitor state basically tells the chip whether to flip-flop or not. Here, I'll eat another donut. Oh. But that's the basic way that the 555 timer can trigger itself. Putting it into a stable mode. And now, we are going to do some really boring crap here. Flip-flop. I like flip-flops, especially at the beach. Alright, so let's do something lame. Let's characterize it using... Oh shit, this is gonna suck a little bit. This is gonna suck a little bit. Okay, let's characterize it with super easy algebra. So we need to get our on and off times. I could just measure it with the scope, but we're gonna do it without measuring it with the scope because you need to know. You don't need to know any of this. So let's check our R1. I didn't actually check and see what value I put in, and you know the math's gonna be horribly wrong, and I'm gonna feel really dumb and embarrassed, and it's gonna probably be kind of funny. All right, so this is gonna be our R1. Here's a trap for people who don't know what they're doing. If you leave it in the circuit, the resistance and stuff will oftentimes change, because there are other elements in the circuit affecting it. So always take it out of the circuit to measure it, dum-dum. It's more true with like capacitors and stuff. Because every element has resistance and capacitance. Sometimes yeah, sometimes it's negligible, but other times it's not so negligible. And then your measurement is wrong. I propose you read this. This is a horror stream. Alright, so that was a 1K resistor. I wrote the K first for some reason. I'm pretty sure R2 is a 10K, but I'm going to measure it anyway. Okay, so this goes from pin 7 to pin 2. Easy peasy. There's our resistor. Just going to measure it real quick. Okay, it's also 1K. Makes life a little bit easy. Wait, isn't it? I'm done. I'm done. Oh, wait, no, I'm extra done. I'm plugging all these in the wrong places. No, got it back. Sorry, I had to plug it back in the circuit. So R2, also 1K. And then our C1 is just a 10 microfarad electrolytic, and I'm pretty sure you can use electrolytics without characterization being wrong or something. So to get, I hope you can read this. If you can't, I'm wasting my time kind of anyway. This needs to be on YouTube, not on Twitch. So if we want to get our low time, which is a little easier, we do TO equals 0.693 times R2, which is just going to be 1K. And then we go times 10 mics, which is 0.00001 farads. And I'm going to have to use the calculator on the computer because I'm not going to do that in my head, even though I really should be able to because it's really, really basic. I'm pretty sure that it's like, let's see, my 1K, so 0.1F to, yeah, it's going to be basic, but I'm going to use the calculator anyway. Otherwise, I'll make a mistake. And then I'll feel stupid. Alright, so our down interval is going to be 0.00693 seconds, and that's going to make it 6.9. Wait, that's not right, because that's the same one up here, and this circuit's different. Oh wait, no, it is right. But I can look and see on the screen that it's wrong. Okay, well either way, that'd be 6.93 milliseconds. And that's very wrong. And I don't know quite why. What did I do wrong? Help. Help. Someone tell me what to do, I'm scared. Can I touch it with the pen? Does this help it? Maybe if I draw on the 555, it'll fix it. 555, more like 554. Oh, I'm being dumb. Okay, so I'm completely wrong, but I'm gonna try something real quick. Yeah, oh, that was the... No! Okay. I'm gonna go back to the oscilloscope. Let's measure the actual values. I bet I'm just off by 10 or something dumb like that. Select view, and then we'll have it measure our low width. Apparently, for some reason, it can't do that. Yeah, see, it's 69 milliseconds. So we are effectively just off by a 10. I'm gonna try and find out where that 10 is real quick. Let's look at my equation. Wait, 1. That's right. What did I do wrong? Oh, I was off by 10 somewhere. Don't judge me. I smell something burning. I got my legs tucked under myself again like an idiot. Okay, so now let's try the other equation so we can figure out how stupid I am. Very dumb. Wait, was I measuring... No, that's definitely R1 and that's R2. So, like if we measure our up width and our down width, yeah, they're practically the same. 178 milliseconds, it's a pretty... I feel like I built the circuit wrong. Which is strange because I've done this a million times. I'm too anxious. I can't do it. Help. Oh. This is a pain in the butt. YouTube's easier. I could just cut this out. How long has it been? Would it be weird if I stopped? A little bit. It's having only been 2 hours. I already built the Atari Punk Console. I shouldn't even do anything else. This is weird. Why wouldn't the capacitor... It should be fully... Well, no, actually it shouldn't be fully discharging. It would completely depend on the cycle. So I want to figure out why the hell it's doing this. And, I know that this is hooked up properly, so it's something else. Oh, I wonder if those leads were touching. That's one bad thing about breadboarding. You can't always... It's not super reliable. You have to take a lot of care to get the connections correct. And just sometimes you just don't. And this one is what? This one's the output. These aren't both the same value, right? No. Okay, so That'd be kind of weird. I'm gonna flip these around and see if we get the right configuration. I've done that one before and it worked just fine. Look at what I'm doing. Ah, no work. Okay. That one's hooked up right. The leads on these caps, or these resistors, are just at this point. Okay. Hey, now those are correct. Okay, we just ignore that last one that I did, because I think there might have been an issue with, I think I might have been going kind of out of range for the, doesn't make any sense, but. Alright, so now we switch the two values. Let's just pretend that this one didn't exist. Wait. I put 1K for both of those? That wasn't right. Oh, it's because I didn't do the second. This is dumb. That's dumb. Don't do that. Alright, so now instead we have this equation up here, which is R1 equals 10K, R2 equals 1K, and C1 is still 10 microfarads. So now to get our load time, we pretty much just do the same thing. 0.693 equals times 3. Yeah, our load time would be times our 2, so it would be 1K times 1 farad. And that comes to, which one is, yeah, the load time, it comes to like 6.93. 3 milliseconds. And if we go over here to our load time width, I don't know how easily you can read it. But this right here, it kind of cycles between 6 and 7 milliseconds. If we went in a little deeper, I think we'd get it more. Yeah, there we go. I'm getting a little more. 6.6, 6.7, 6.8. It's hovering around the 6.9 milliseconds, so that's correct. See, I'm not stupid. And so now if we want our I mean, it happens a lot, but, you know, still, they didn't do it on live TV, like I'm doing. And this time it's gonna be 1K plus 10K times, and this will come out to be 76.23 milliseconds. And if we back up, it's a little bit longer, so being backed out will help it calculate if we back up. And if we see it right down here, we're looking at about 76, 77 milliseconds. Therefore, our equation is doing what it's supposed to do. The capacitor is charging up at the speed we're calculating, and then once it hits the threshold, it discharges, and the signal drops low, and it comes back up. So that's how 555 timer works in a stable mode anyway. The other modes you have to put a clock in. They're not as useful for basic building blocks. They still work great for certain things, and you can actually use them for logic and weird junk like that if you want to putz around with that. And I'm gonna rebuild the Punk Console, I think, and then I'm gonna call it a night. I thought this would take a little bit longer. I'm probably going to design a board for the Punk Console. Uh-oh, I lost everyone. Well, not everybody, but a lot of people. Okay. I'm going to take these out. And I'm gonna whack both of the 5x5s in and get them just like totally chilling out with each other. Let's take this out, so I'm happy to. I can put this back here. I take you out, I take you out, I take you out, you out. Okay. I'm gonna try and build a clean implementation on the board. Oh, that's not really cool. clean looking. And I could actually get by with not using a second rail if I just did this. No, I'm the bad one. It's just weird how streaming can be like that. Like, I'm sure some people when they stream, they just feel great and don't notice anything. But like subconsciously, my brain just goes into a weird ass mode where I can't. I don't know. I just like I kind of block out on things. It's annoying. Super annoying. Okay. You know what would actually be kind of cool, though I'm not sure. Not sure if I can do it, but it'd be kind of neat to, no, it would mess with the signal. I'd have to, I might try it, is put some LEDs so they blink at the speed of the oscillation. Since their on time isn't 100% duty cycle, I think maybe it won't hurt them even though they're getting blasted with like 9 volts. We might try that as an end thingy. Okay, so you are the reset pin and you need to be high, just like me. Ah. Wait, I'm completely off my circuit here. There we go. Good night, Dad. Yeah, no worries. Thanks for watching. I know it's kind of dry, as usual. Gotta figure out a way to make it less dry. Okay. Let's go ahead and install our big buddies. I'm kind of butchering the holes on the board when I install these, but I mean, I guess I'll be okay. I didn't think about it, but I could actually tie these two. Oh, would that couple? No, it wouldn't. Okay. I can actually tie these two. Actually, there'd just be no point in doing that. But I could effectively hide these wires by moving these forward a couple of paces. Running more holes in my board. Okay, a shorter one. Ah. All right. Atari Punk Console version 2. This one will probably suck even more. Have you already taken your Benadryl? Acrizin. Acri. Yeah, you did. I'm just curious. I'm not going to take mine for a while. It used to be kind of nice to stop for an early night, even though it's the first night back. Okay, give me the Punk Console. Kind of trying to do a little bit of layout here first, so I don't have to scramble as much. Alright, I think we can do a basic ground here. Don't know if you can hear those stomach noises, but they sure feel good. Alright, so I got the basic layout done. Is there anything else I have to care about? I mean, yeah, I have to couple the I have to couple these push button dealies. Hi, it's 9:30. Time for my Bennon drill. I wish I could just clip these right to the... I mean, I technically can, but I don't really trust them. Okay. Alright, so we're gonna connect you to the output and connect you to the input. At least these wires will be kind of down here and out of the way. I'm a sucker for reorganizing all this. A bit of bus cabling kind of stuff going on here. Where's the other one? I had two. Where did the other one go? I lost the other one. It's probably on the floor. Oh, it's down here. Got this whole tangle of wires. Just gonna tangle myself up in it. And it'll be like, no, I'm not gonna make a reference to that show. Actually, I can probably go in from behind. I'm gonna need to get that like that. There we go. Perfect. Perfect. I could probably put this one back here too. Like that. No horrible wire mess. Or at least, not as much. I'm actually not quite sure how to solder these FSRs. I've never done it before. Assuming the backside, you just pin it up and kind of leads to it. Alright, so now we got our two controls basically set up. We've got our 555's powered reset pins pulled high. No. Oh, this guy's not grounded. And that would have been an annoying little thing to forget to do. Ow. Yeah, my stomach's like a mess now. Get it. I also have the window open. It's 20 degrees outside and I'm starting to sweat a little bit. Okay, let's just see if the light turns on. It does. Alright, so we've got all of our controls. Our battery, our thingamadoopter popped off. Thingamadoopter. Reinstall the newest Windows feature update. Take a time. Never. What about like 4 a.m. Thank you, go away. Okay. Yeah, it's in the Windows open a pretty decent amount too. I can't remember if this thing does capacitance and if it does it properly or not. Let's check and see if the multimeter does capacitance. I don't think it does. Oh, yeah, it does. Alright, so C1 on 5551 is supposed to be 0.01 microfarads. I don't think this thing's going to be sensitive enough, but it's also, I think, really slow. But I've never used it, so let's see what we got. This little convection oven? I mean convection? Convection? I mean, I guess convection oven. Like, I've never heard of an oven that's just for sugar. or like pastries. Oh, I can't set the range. It actually does an okay job. Let me check something real quick. Yeah, typing on the phone is pretty dumb. Okay, so this is confirmed our 0.01, wherever it went. Oh, it's right here. Okay, I just wanted to confirm the capacitors as well. I'm kind of proud of my meter. I didn't think it would be that accurate. And it's recommended by Dave Jones himself, so. Yeah, I can't swipe with, I can't type with swipe. I don't know, just can't do it. I got a problem, I don't know, but can't do it. I always mess up. And then I get irritated at it. Like, I'm like 80 years old and can't type on a phone. But I just type with my thumbs, like a normal keyboard. Alright, so I'm trying to use as many leads as possible so I can have kind of an okay looking circuit. Reset VCC. Now I had a bad Larry. Yeah, cool. Okay. But you're not long enough. One of these jerky boys in here. Okay. So the output of that needs to go into 7. I feel like I could probably find a better wire for this, but I'm cool with this. And then the output for... I'll build them one at a time. Okay, so our discharge comes out here, and then we have a 1K ohm resistor. Make sure this is it. Nope, you are a 10K. It's weird. Every once in a while I stop and I try to learn how to read resistors properly, and then I learn how to do it, and then I just forget because I have them all sorted and I don't have to think about it. Okay, and then discharge to threshold. Perfect. Okay, so I got discharge to threshold. That's that. And then we need to take our threshold pin over to our trigger pin, which I can probably use a white wire for. Is it 6 to 2? Six, 2, 2. I think I got it. It's all I wanna do. Not quite. Got this going to trigger from the threshold. Perfect. Now we need to take our output for this IC and put it into the input for the other 555. Easy. Sort of easy, anyways. Alright, now we need our other capacitor. And I'm gonna go ahead and measure its capacitance. Looks like we got 10 nanofarads, so it's not the right one. 203, what do we got here? Also a 203, so I think I need to get a 204 or a 202. One second. This is a 104. What am I doing with that? Oh, my wait, they are ones. I'm stupid. 3, 4, 101. I think I brought the whole bag of 102s back over here, didn't I? I brought the whole bag of 103s over here. One bag. 103, 104. I am sad. I need 102s. Help. This is dumb. Where are they? I lost them. I think I might have lost my 102. Oh. Let me check my phone really quick. Cupcakes has a shiny mask. Ooh, it's pretty. All right. So, since we don't have any 102s, let's see what the 104s are. So, is it going to be 100 nanofarads? 50? They shouldn't be 50. That's wrong. Not 50 nanofarads. Oh, I'm holding it with my hands. It's stupid. No, come back. Come back here. No. $104. This should not be 50 nanofarads. No, we're whacking it in. I think it's exactly what we want. Okay, this time we have to go out on the threshold, so that's going to be CX. Alright, and then we couple our discharge and our threshold together. We don't have any sort of divider because our discharge isn't, I don't think we care as much about it. Yeah, I think this would definitely be a kind of a better as a YouTube thing. I could put up diagrams, do all that stuff. And the capacitor input is up on the pin 7. Alright, that's easy enough. Gonna need a long one for this guy. Pin 7. Alright, that's pretty solid. Now we also need signal out. I'm gonna do the super long ones for this. Okay, maybe only slightly super long ones. Yeah, that's good. Alright, what the hell else do I have to do here? Got ground, trigger, signal out, which is filtered, bypass cap, and then you've got your reset pin for pin 8's VCC, this whole discharge network, we have this thing coming from here. And then we've got that going to ground, right? Yeah. Well, technically, if I haven't hooked anything up wrong, this is it. It's a good. That sounds like somebody screaming a little bit. Help! Help! I'm jamming out, guys. That sounds really cool. I like it. Oh yeah, it's terrible. Alright, well I managed to keep enough, even though I built the circuit in the first 20 minutes, I managed to keep like some content going for 2 hours, so yay me. Yeah, I think this is fairly niche. Yeah, it is like a seagull from hell. I'd like to build more mechanical things, but mechanical things are expensive. I guess just stuff with motors. I need to build that slapping machine. I really want to build it. I've got the motor control and everything. I actually don't know what I would use to hold it on the stand, because it's a really powerful motor. It's like a drill motor. So like, it will just rip itself off of any mount. I'm gonna have to like ask a metalworking shop to build a mount for it or something. Then I could hook it up to a WeMOS board and you guys could send signals to it and they could hit me. That'd be great. Whenever I make a mistake, donate biddies. Donate biddies for slaps. I'm not a weirdo. This is just how entertainment works now. Yeah, let's have an outro song real quick. I'm making music. Alright, that's our outro song, and with that, I'll bid you adieu. I just got a Snapchat, so good timer. Please join my Discord and tell me what to do because everything I think of is boring. I guess that's it. I'm gonna go take some cute Snapchat pictures or something. That's the 555 timer. And the Atari Punk Console with a few little modifications. I'd like to add a sequencer to it, I think that would be cool. But sequencers are hard to build. I'll do the little 8 sometime or something. Good night, Acri, my most faithful viewer. I thought about it, but I'm not gonna go back there and get it. But I really want to. No. Before I go, I need to adjust the scenery a little bit. It's in a bag. It's gonna be so hard to tell. Okay. Let me go back to the DSLR. Okay. Yeah, you can't really see it. Ow. Boo. It didn't really, you can't really see it. Anyways, that's gonna be it for me, and I'm a kitty cat, so please send fish, I guess. Maybe next time we'll do something that you want to watch, and